Rahim. This lecture is on mapping of entity relationship models into relations. Um, the idea of this topic is to convert the entity relationship diagram into relations so that it becomes tables when we come into the implementation phase. So usually if we look at the naming conceptions here, these concepts um, are used interchangeably. Like the name entity means relation, and the relation means table. Um, Likewise, the attribute becomes the column or the field of the table. So we have three types of mapping of entity relationship models into relations. These are one-to-one relationships, or mapping one-to-one relationships into relations, or one-to-many, or many-to-many, according to the degree of relationship that we have into the model. Before we start doing that, let us first define this concept. A relation. What is a relation? A relation is a table that holds the data we are interested in. It is a two-dimensional item or object and has rows and columns. Of course, we know the table. We have done it many times. We have created tables using SQL, and we know that the headings are these columns or the field's name. So if we have a student, and these attributes become columns. So if we have a relation called student, student with student ID, student first name, student last name, student major, student core, student grade, GPA, grade point average, or student, for example, address, phone, whatever. All these are attributes. These attributes will become columns. One of them will become a primary key that uniquely identifies the rest of these records. So a relation is just a table, because a relation usually it was an entity from the in the entity relationship model. It is called entity. In the relational model, it becomes relation, and in the implementation phase, it becomes a table. So each entity type in the relationship in the entity relationship model is mapped into a relation, and these attributes will be converted to columns, and the values of these attributes will become the rows of these tables. So let us start with the first one, which is mapping one-to-one relationship into a relation. What is one-to-one relationship? We have given examples, two examples before, which is like one president and one country. Like one president rules or governs a country, and each country is ruled by only one president or governor. So the relationship here is one-to-one. How do you read it? You read like this from the two sides. Each president rules one country, and every country is ruled by only one president. So this is just one-to-one relationship. Also another example like car and driver. If you'd like to read it from both sides, you can read it from this end or from this end. You can say a driver drives only one car. A car is driven by only one driver. So I have this example here for you to explain that relationship between driver and car, in which you could see that here we have a driver entity and a car entity, and I have some attributes for each one of these entities. For the driver, I have the driver ID, which is a primary key. That is why it is underlined here. the name of the driver, the address of the driver, and age. So I have these three attributes. It could be more. I'm just doing here 4 of them. And on this side, I have a car entity in which I have 3 attributes. These are VIN number, which is vehicle identification number, and make and model. So this vehicle identification number is a primary key of this car entity. So this relationship could be read from both sides, as I said before. Like you can say driver drives one car, one driver drives one car is driven by one driver. So the question is how we map this type of relationship into relations. Here I have 3 different options. The first option, you create this as only one entity. Yani you consider the 2 entities as only one entity and group all of these attributes into that entity, like this. Here in this example here we have, for example, we said a driver car, like both of them we consider them as one entity, and then we put all of these attributes, 7 of them, into this relation, so that we have driver ID, name, address, and then vehicle identification number, make, model, and age. All of them here is in this merged, amalgamated or merged entity, in which we decided, of course, each entity or each relation must have a primary key. So here we put driver ID as a primary key, or we could put a vehicle identification number, only one of them, either driver ID or vehicle identification number that uniquely identifies these records, all of them. But doing it like that, it can have a lot of problems, especially if the 2 entities represent different worlds. Like these 2 entities, driver is representing a person and car is representing a thing. So there is no relation between a person and a thing like car. I mean, you cannot just mix these 2 different attributes together, because each one of them has different attributes or values that describes it. Also, there is some problem that can emerge. What if I have age also here? This age, I will be confused, or everybody will be confused. Age, what do you mean by age? Age, is it age of the driver or the age of the car? So that must be clear here in this kind of relations. So this is one option, but it is possible only if we have the two entities represent something similar, like a doctor, specialist, for example, and houseman officer, or some people are the same people. They are just different in the job that they are doing, but they have a name, it refers to a person, address refers to a person, like something like that. Then we can have such kind of this relationship together. But if it is something like contract and employee, we cannot just merge both of them, because one contract is done by one employee and an employee doing one contract. If it is one-to-one like that, it is less likely to be considered as one entity, and those all attributes are meshed together. So this is not the best solution. It is the best solution only if they are representing similar entities, or entities that are very close in the real world, in the real life. That's why they are suggesting to have them actually 2 different entities like this. Driver has its entities, which is driver ID, name, address, driver ID, name, address, and also age. There should be age also here as part of this entity, age. And I'm gonna put VIN number here. I'm gonna talk about it in a minute. This VIN number here represent a foreign key of the other relation, which is car. So I have car, vehicle identification number, make and model, and I am actually making the relationship through the VIN number, which is the primary key of the car. So the primary key of the car VIN is existing here in this in this relation driver. So the VIN number exists here as a foreign key to make that relationship between car and driver, because if we have to have a relationship, there must be one of the entities primary key existing in the other entity as a foreign key, so we can have this choice. Or the other way around, you keep the driver as driver ID, name, address, and also I forgot here to put age. Let me just add age to this. Okay, age. So age is there. Now driver ID, name, address, and age, exactly like this, with the driver ID as a primary key. But you see the driver ID exists here in the car. So driver ID exists here in the car as a foreign key, because car has basically VIN number as a primary key, but make, model are just normal attributes. But we have an additional attribute here, which is driver ID. What is driver ID? Driver ID here is a foreign key that comes from the driver. So either one of these options can be used to represent that kind of relationship between the two entities, driver and the car. Again, it is two options, whether to consider them as one entity, and it is preferred only in cases when there is similarity between the two entities, very similar things. For example, two persons like manager and assistant manager, or pilot and assistant pilot, for example, pilot of the plane and his assistant. Both, if they are representing two different entities and each one has his own attributes, then they can be actually every pilot is assisted by only one assistant, and every assistant has only one pilot training him. Then this relationship is one-to-one, right? Is one-to-one, but they are so similar in everything, almost everything, except in the job description. This is a pilot and this is a system pilot. So in this case, I can actually merge these two entities together and call it a name like pilot and assistant together, and then put all these together in one container as one relation, and then just have one primary key for that relation. That can be done. But if the two two entities, they have this kind of relationship between them, one-to-one, but they are different. They are different, like driver and the car, for example. As I said, work contract and employee. These are two different, two different things. Each one has its own different attributes. So in this case, it is not preferred to use the first option, but the second option is preferred, which is in the second option, as I said, either you consider one primary key of one of them as a foreign key, or the other way around, the second one primary key considered as a foreign key in the first one. So this is how to map the one-to-one relationship. Then here we have how to map one-to-many relationship into relation, which is most common relationships in the real world. Most common relationship. Most of the relationship in the real world are one-to-many relationships, and we have a lot of examples that we mentioned during our classes. And here I have two examples that I can provide to explain this. For example, if you look at this entity relationship diagram, which represent course and section entities, such that course has course number as a primary key and has title and credit hours, and on the section we have section number is a primary key and room is another attribute. So in the first one we have course number, title and credit hours attributes, and in the second one we have section number and room as attributes, and each one we have a primary key as you see underlined. So the relationship here, it is considered one-to-many in this example, such that a course has one or more sections, and we see that this is the Krauss Foot model, in which you see that one here, that means only one course has at least one section. If it is registered, if it is offered, then it has at least one section, but it can have many sections, as in this example. So this is a one-to-many relationship, and it is very clear here that the foreign key of the side that has a many, the side that has a many is a section. The primary key of this one should exist as the course number of the parent table should exist here in this entity as the foreign key. So if you'd like to map them, list all these attributes of the parent. The parent means the one that has one side, has a one, not the many, which is the course. List all of them like that. Course outside, and then between two parentheses, the list of attributes separated with commas like this: course number, title, credit hours, and course number is underlined because it is a primary key. And then list also the same thing, list the attributes of the second relation, write the relationship outside like this section, and then section number, room, and course number. Now you can see that I have this course number is not basically one of these attributes that basically has been seen in this entity relationship drawing, but here it is considered to be what? To be a foreign key. A foreign key, that means it is a primary key in course, and it exists here as a foreign key, such that there is a lot of if you see the course number repeats in the section, that means there is a lot of courses that are offered, and each one of these courses has many sections in them. So this is one example. The other example that I can show you, this one, which is a common example that we have shown you before, the relationship between department and employee, such that a department employs 0 or more employees. When you see this small circle here in the Krauss Foot, this white circle, that means 0 or more. Not like that example which we have seen, like at least one section. Here that means 0 or more employees. That means some departments might not have any employees, but a department might have also many employees in it. From this example, you can see that this department has department number, department name, and location as attributes, and department number here is a primary key. And on the employee here, I have also 4 attributes, which is employee number, employee name, job, and salary, in which employee number here is a primary key. In this case, again, like the first example, like the previous example that I have shown, you take the primary key of the parent here is department, and the primary key of this department is department number. You take it and make it as here as a foreign key in the in the child table, which is employee. In such a case, you will see that the mapping will be like this: department outside parentheses, because it is an entity, and then between parentheses we have department number, department name, and location, which is only the three attributes that have been designated for this entity. But the second one, employee, beside its own attributes, employee number, name, job, and salary, we have an additional attribute, which is the department number, and the department number here is considered to be a foreign key because it comes from department to actually portray that or to make that relationship between department and employee entities. We can have a lot of examples, but the idea, I think, is very clear. Let us move on to give another example for mapping, and this is this one here, the many-to-many relationship, in which we need to like walk another step or do something more in order to represent this kind of relationship, because in the real world it is difficult and it is actually impossible to represent many-to-many relationship in any database management system. So we have to make some sort of maintenance, I would say, or some sort of kind of operations in order to create such mapping, and later to create these tables. So let me talk about this in this example. Assume that we have a relationship between student and section, and assume that a student and section, the relationship between them is many-to-many. We can read it like this. A student registers in many sections. Like one or many. You can have a line here to identify that at least one section. Or a circle to make it like a student can register in 0 section or no section or many sections. But whatever it is when many-to-many. In such a case, a student registers in many sections. If you'd like to read it from this side, a section has many students registered on it. So many students registered in one section. And we have talked about this example before, and we understand how it goes, right? So here, what is important for me is to look at the attributes of each one. The attributes: student ID as a primary key for the student entity, student name, another attribute, student date of birth is another attribute. And for the section, we have section number as the primary key of this entity, and location. And look at this this relationship name is called registers. And we have here, this is what we call relationship attribute. Relationship attribute means an attribute that doesn't come on the student or the entity, or doesn't come on the section entity, but it comes on the registers relationship. We have a lot of examples here about this. For example, if you have a contract, an employee, and you have, for example, I would say wage or like price of this, or the cost of this contract. You cannot put it on the employee, and you cannot put it in the contract, because if you read it logically, you will see that the money that they're giving for the contract, it is for both of them, because the money is for the contract. Okay, and the money is going for the employee, so it is actually the best be represented to go into this relationship name, and that will become an entity. This relationship name will become an entity. But here, for example, registration date of the course, right? Of the course or the section. So shall I put it on the student registration date, or shall I put it on the section? It could go in both, right? Student and registration date of the student. or section and registration date of the section. That means when this section has been registered on it. So that's why it is actually best be represented here as an attribute that belongs to this relationship, which is called relationship attribute. So we put it here, because in all cases this entity relationship diagram will be converted into 3 relations, not only 2. So student and section and registers, such that the student ID will become the primary key of the student entity, but beside I put student name and student date of birth. So this is clear. And let me go here to this one, which is section number will be a primary key plus location, like section ID and plus location. So the primary key of the section is this section number, and the primary key of the student is the student ID, of course. And then here I put in the middle here this this one here is my third relation, which is, I can call it student section, or I can call it the name itself, registration. Yeah, I can call it registration or registers. You know, it is best to be called close to the name of that relationship name. So if I would like to call it registration, so it becomes here my third entity my third relation that connects both student and section. Then the question is, what are the attributes of this new relation? The attributes are basically the primary key of the first entity and the primary key of the second entity plus the relationship attribute. So we have student ID and student number. Both of them together, student ID and student number, become the primary key. Both of them become primary together. We call it composite key. But each one of these, it is a foreign key to its entity that it comes from. So, for example, student ID is a foreign key to the student entity, and section number is a foreign key to the section number in the section. So if you look at it individually, each one of them is a foreign key. But if you have been asked what is the primary key of this relation, the primary key is both student ID and section number, which is called composite key. And then there's a normal regular attribute, which is registration date. This one, which is actually the one that has been assigned to the relationship name. If you look at the redrawing of this one, after it has been mapped to the relations, you will think about it like this. Yani actually before you transfer it to this relation or mapping, relational mapping, then you look at this part. Create section and create student and put student section or registration as we named it here, and then take the primary key of the first one and the primary key of the second one, put them here as composite keys, composite key, and add to this new entity the attribute here that has been put on it, which is the relationship attribute, such that the relationship like this. So one to many from this side, and one to one from this side, one to one from this side, and one to one from this side. So a student ID will appear only one time in the student table, and section number will appear only one time in the section, but both of them they repeat here. So we have a lot of student IDs, we have a lot of section numbers here in this relation. I think I have seen that in an actual table after it has been converted from these relation into the tables. Let me see if this is the example that I would like to show you about mapping of student and section. So here it is. Yeah, if you would like to look at it here, this is basically student. This is, let me just put this drawing here, and so here I have my student relation, which include the student ID, student name and date of birth. Here student ID, student name and date of birth, and we have course number, and I think this is a different example, I guess different example, but let me go to this example here. This is the example. These are my tables, in which we have the first table. This table is this one here. Let me name them. This is student, and this is student section, or we call it registration in that example, and this is section. If you look at them, the student has student ID and student name and student date of birth, right? In which student ID is a primary key. That's why you don't see here it repeated. Every student is unique. 11, 22, 33, 44, 55, 66, 77, they are unique, okay? And each one has a name and date of birth, so don't worry about that part, because what is important here is that we have a lot of students and each one has an ID which is unique. Come here to the section. Also, we have the same thing here. We have many sections, but they are unique. That means section numbers are primary keys for this one. They have location, different location maybe, or same location, it doesn't matter. But here, what is important? This one, which is a primary key. Now, look at my newly created relation, which is this one, the student section, in which I put student ID and a section number here, student ID and section number, plus registration date here, which I can fill it with registration dates, different or same registration date, it doesn't matter. What matters, I would like to show you this. What is the primary key of this? The primary key is these two together. So the primary key is these two together. Let me put them, this different color. Together, student ID and section number. Together they are primary key. But each one of it is a foreign key to its primary key that for the entity that it comes from. So student ID 11, but you also see 11 here and 11 here. These two here are also, the same student. This student here is taking section number 1, is taking section number 2, and is taking number 3. This student is taking these, these sections, right? Okay, good. So, do you see any repetition? There is no repetition, because 11 and 1 is not like 11 and 2 or 11 and 3. If you take them together they are unique. But there is repetition here because it is a foreign key. Also, you'll see repetition here. You'll see 1 and 1 and 1 repeated, because section number 1 is taken by student 11 and student 22 and student 44, which is normal. And also you see 3 repeated twice, because it is taken by student number 11 and student number 33. So if you look at it, you will see that these two attributes will make the primary key together, such that a combination of them will be repeated. No combination of them will be repeated. That is why it is a primary key, a whole the whole two attributes as the composite key, we call it. And so now we ended up having what? How many relations? Three relations. The first one, student, and the second one, section. But we have created this one to make that relationship between them. In this case, you will see the relationship is one to many from this side. Yani one. Let me, if I can insert, I would like to insert an arrow, just an arrow to point that the relationship here is one to many from this side, one to many from this side, and it is also one to many from this side. Yani that means you will see one occurrence from this side, but there is many occurrences from this side, because one here you can see 1 1 1, and also this one, it is one to many from this side, because as you could see here, that means 11, for example, can be repeated many times, like 11 11 11 and so forth. So this is one to many from this side and one to many from this side, as I mentioned in my previous here, like this here, one to many, one to many. So this is basically to map the many-to-many relationship, entity relationship models into relations. So I guess it is not that difficult to understand how you follow the steps of converting these entity relationship models into relations. And please review these chapters also for more information on this topic. Thank you.